So students, now let's look at Prims Jarnik algorithm, another algorithm to form an MST. It's also colloquially known as Prims algorithm. It's also a greedy algorithm. So now let's see how it works. So for example, in this case, in this algorithm, what we have to do, we have to select first of all a start node. Now start node could be any node of this graph. So here we started with A. Now once we selected A, we'll have a collection of edges corresponding to A, right? So what are the edges which belongs to A? So 8 and 10. So in this we add this collection. In this collection we added these edges. Now out of these edges you have to choose the minimum one, and here that's why this is known as a greedy algorithm. Of all these edges in this collection, we'll choose a minimum edge, and that edge will put into our set of edges of a minimum spanning tree. Means that this particular edge is definitely going to be in our minimum spanning tree. Okay, so what we do is that we take this edge out and add it into this our minimum spanning tree edge. Now what, with this edge taken, we have now also discovered the node B. Now once this node B is discovered, so all the edges corresponding to this node will also be added into this our collection of edges. So what are the edges corresponding to B? 15 and 9, correct? So let me add 15 comma 9. Now once again we'll choose the minimum of among all these edges. So in this case, which edge will be selected? So since this edge is selected, let me mark it bold. Now out of these edges, which edge will be selected? 10. Oh, I'm sorry. I'm sorry. So out of these edges, which edge will be selected, which is the minimum? So in this case it will be 9. So let me add 9 to my minimum spanning tree and continue. Now with this edge being selected, we have now discovered C as well. So now my collection of edges will also have edges corresponding to C, which in this case would be your, which one? 12, 20 and 18. So it will be 12, 20 and 18. Now what can I do? Definitely I can remove these edges completely because they have already been selected, and now out of these I have to select a minimum. So which will be my minimum edge now? It will be definitely 10, right? So I take this edge and put it into my minimum spanning tree edges collection. So it means now this edge is also part of a minimum spanning tree, just as 9, correct? So as soon as I have included this edge, I have also now discovered this vertex D, and I have to add edges corresponding to this vertex into my collection of edges. So what else, what edges can I add now? 15 is already there, 12 is already there, now 25. Okay, so now it has 25 as well. Well, again same approach, I have to select the minimum. So minimum out of this is 12. Now if I take this 12, what will happen? It is the edge to the already discovered node, so it will form a cycle. Definitely will not take it. Then we have to take, so this is somehow cancelled. Now we have to take the 15. The 15 will also do the same thing, will also not select 15. Now what are the edges possible? Out of 20, 18 and 25, which is the minimum? Definitely 18 is the minimum. Okay, fine. Now once I have selected this edge 18 and added here, again I have discovered one more new vertex F. So let me mark F, add discovered, and now in my collection of edges, I have to also take edges corresponding to F. So what edge would be added? 14, right? So let me delete this edge, and into this collection also these are also not to be taken. So these are done. So now let me add 14. So I have now 14, 20 and 25. So out of this, minimum is, I have to select the minimum. Minimum is 14 and I add it here. Now for 6 vertex graph, how many edges do I need to have to form a minimum spanning tree? As you already know, n minus 1. So it would be 5 edges, right? So let me see whether I am done. 1, 2, 3, 4, 5. I am done. And finally, with this 14, I have to also mark this out, correct, as bold. And this is my spanning tree. I can remove all the other edges. And now what will be the cost of this spanning tree? Simple, it's 8 plus 9 plus 10 plus 18 plus 14. I hope this is clear to you. Now let's also practice quickly this algorithm on this second graph. So very simple. Now I'll go a bit quickly. Now we'll select X as our start vertex. Minimum edges 5 and 10. Out of this, minimum is 5. I selected this 5, and in my collection now I added 5 and 10, and I selected 5. Now this node is also discovered. Why? So what are the edges corresponding to Y? 8, 15 and 20. Let me add 8, 15 and 20. Out of this, minimum is 8. Let me include into the minimum spanning tree. Now U is discovered. How many edges are connected to U? Only one in this case, that is 12. Let me again choose the minimum out of the possible edges. Minimum is 10. So let me remove this 10 and add to my minimum spanning tree. I have added this 10. Another node discovered is Z. Edges connected to Z which are not yet been discovered. Let me give this edge a name as let's say 22. So out of these you'll have 15, 20 you already have, add 22, and now out of these, time to choose the minimum edge, it would be 12, right? So let's choose this edge 12, and how many edges I've chosen? 1, 2, 3, 4, and since my graph has 5 vertices, 4 edges are chosen, so this is my minimum spanning tree. I can remove all these edges. Cost of this minimum spanning tree would be simple, 5 plus 10 plus 8 plus 12. So this is how you run a Prims Jarnik algorithm onto a graph to get a minimum spanning tree. I hope it is clear now. We have not delved into the details. In the subsequent lecture, we'll see how to code it. We'll have a pseudocode. We'll see the time complexity of both the algorithms and definitely solve some questions. Thank you.